So there's three things I want to go over in just kind of some general broad strokes to help you in working with Python. First, I want to introduce you to Python and some of the basic functions and commands that come with Python. Everything from printing out content to the screen, as well as getting input from a user. Then we'll look at how do we use some basic math functions, because math is often used inside of a programming language. Now, it's not always, and you don't have to be good at math because the computer is going to do it for you. So don't worry about that. As long as you understand how to do it inside of Python, you let the computer do the heavy lifting. And that's really what computers are for, is to do the work for you. You tell it what to do, it does it for you. And it can do a lot more work a lot faster and with more repeatability than you can do. And so we want to talk about using computers in that function and format. Finally, we're going to look at some common mistakes that people often make in Python and other programming languages, as well as how do we solve them and some other tips and tricks that will help you work with your programming. So let's go ahead and get started. So here I am inside of Visual Studio Code, and we recommend that you use Visual Studio Code or Visual Studio at Tusculum because we're going to be using this in other classes. Both Visual Studio and Visual Studio Code support multiple languages. A lot of people find Visual Studio Code to be a little bit easier to get up and running and started, and so if you're taking an introductory course, that might be what you prefer. You'll also find it's a little bit more consistent between different operating systems, where Visual Studio doesn't always support all languages that it supports even on all programming platforms and operating systems. So that's something you want to be kind of careful of. Now, Visual Studio Code has a great place in helping us get started, and I want to show you a couple things that I've done to make working with it a little bit easier that you might want to consider as well. One is I'm going to go to File, and I'm going to choose Open Folder. And Open Folder allows me to open a folder and store all my project files inside this one folder. That way I can organize and group together projects. And if I have a large project that's made up of multiple files, then I can subdivide it down or maybe just create its own separate folder, and it lets me be very organized. Very, very helpful when you work on large projects. Now, what I've done is I've just created a Python folder here. I'm going to select it and then choose Select Folder. My left-hand side is going to list all my files I currently have, and notice right now I don't have any files showing. That's because this folder is currently empty. When we start, we have a Get Started screen, and I can choose the New File. Now, when I do, in my case right now, it's coming up with a list of files that I can start: a text file, a Python file, Jupyter Notebook, or a new Java class. And that's because those are some of the languages and support that I've added to my Visual Studio Code. You may not see this, or it may just create a blank text file. If you select text file, you'll notice that it's going to get you this option, which says, please select a language or open a different editor. So I'm going to choose select a language. And this is all the languages that Visual Studio Code currently supports. Notice this a lot. Now, if you don't have Python currently installed, it might ask you to go in and install something called an add-on, and it will do that for you automatically. It goes out, lets you select one, and installs automatically for you. You can find more by looking at these extensions and find them there. And go back to my files, and let's look at our first Python file. And a very common thing whenever you start with a brand new programming language is to print out Hello World to the screen. And in Python, this is very simple. We're just going to use the print command, open and close parentheses, because this is actually a function call. Notice that Visual Studio Code is going to bring up a little box. This is telling you all the different things that you can do with the print command. We're not going to worry about that just yet. We're going to look at some of those things later on. But right now, we're not going to worry about that. What I want to do is I want to print a string literal. A string literal is basically literally what's inside my string. To do so, I'm going to use the quotes. Notice I have double quotes here. And I'm going to say hello world. That's all I have to do. And I'm going to click the Run button up in the upper right hand side. You're going to notice this little triangle. If you don't have the Python extension added, you may not see this. So you might have to go to your extensions and add that. It's going to ask us to save this file. So you can say sample01.py. .py is the default file extension you're going to use for Python. There are a few others, and you can see that listed there. But for almost everything we're going to use, .py is going to be appropriate for us. Click Save. And now I'm going to click the Run button. Notice it comes up and says Hello World, which is down there in the output terminal. That's what you'd expect. It's what you saw. Now, you might ask, why did I do something like this? It's so simple. Well, that's partially why you did it, because it's very simple. This has very little chance of having an error because you're only dealing with one command and one string. The literal string is what you see inside of your quotes, and you can think of a string in very simple terms of anything that you see on your keyboard that you can type. Now, when we get into a little bit more advanced things, you'll find out there's more things that you can put into strings, especially if you're using extended UTF character sets. But for right now, we're just going to focus on what you can see on your keyboard. This means it can include letters, numbers, special characters, like in our case, the exclamation point. You could also have quotes, asterisks, and many more characters. So anything that you put inside this double quote is going to be printed out. You're going to notice that it prints out to the screen. Now this does a couple of things for us. Number one, it makes sure that our Python extension is properly installed and that we have Python properly running on our computer. If we don't, we're going to get some sort of error message and we'll have to debug and troubleshoot that. But with this, it's very simple to know. Number two, it's very simple to test and make sure your editor is properly configured. So not only do you have to have Python properly installed, but you have to have it set up to run, in this case, in Visual Studio Code. And so this is just led us to a couple of really quick tests to see if this is working. Now, there are a couple of issues that you might run into. So let's talk about those just real quick. So for example, I have print, but what happens if I were to leave off the T? Well, print is not a built-in function or command to Python. And so if I hover over this, you're going to notice there's a little underscore line, and it's going to come up and say print is not defined. This means that Python doesn't know what to do with it. If I come in and I try to click on the Run button, you'll notice it's going to give me an error. Now, it's not going to try to fix it for me. It doesn't know what's supposed to be there. Maybe you forgot to import a command that has that function print, and it's in a separate library. It doesn't know it, so it's not going to try to fix it. It's just going to let us know, hey, there's an error. And it lets us know both when we run it, it says on line 1, and lets us know where it is, and also in our editor. So this is one of the more common errors that we're going to potentially see. And it's an easy mistake to make. It's what we call a syntax error, where we're not following the language structure and rules. It's easy to fix. We just type in print. Now, a second error that we might run into, and this is a little bit more language specific to Python, is what happens if I have... Now, a second potential error you might run into, and this is a little bit more specific to Python, is what happens if I have this? Now, you might go, well, wait a second, what happened? There's no difference there. But notice that print is now got an underline, similar to what I had before, but instead of being yellow, it's red. So yellow is more like a warning. We think there's going to be a problem. You might want to check this out because I don't understand something. Red is you have a problem, and I know what it is. So Python is very specific about spacing and indentation especially. We cannot mix indentations like tabs and spaces, and we cannot have leading spaces if it's not supposed to be indented. And I have put one little space here, and so it's letting us know that there is some unexpected indentation. And this is an easy mistake to have. It's really hard to find because how big is a space? That's the nice thing about working in something like Visual Studio or Visual Studio Code is it's going to help find these types of things for us before we have to even run this. If I go and I run this command, you're going to get an error message. Notice it's going to point to it and it's going to say unexpected indent, which is basically what this error message here is telling us. Okay, so this has made it a lot easier to find. When I first started working with Python, I was working like a plain text editor. Those were very difficult to find. This is real easy, and this is another common mistake you might see. Now, another thing that you might find, and the last one we're going to have, is on how do we handle our hello world. You might go, well, what do you mean, how do we handle it? Well, we might say, hello world, and I'm going to put an extra quote here, said the new programmer. And you're trying to put quotes around because that's what a person's saying. But notice that there's a little error message here. If I put my mouse cursor over it, it's unfortunately kind of wanting to hover over it. But now we can kind of see it a little bit better. And sometimes when we see this little error message, we have to find the right spot to put our cursor. But you're noticing it's saying that, hey, the parenthesis wasn't closed. You might go, well, what type of error is that? Yeah, it is. I can see the open one and the closed one. Well, you are right. And this is one of those things that you've actually confused the editor. And you might say, well, how did I do that? Well, every quote has an open and closing set of quotation marks. In this case, double quotes. Well, I have an open and closing set, and so it's expecting to see a closing parenthesis, not hello world. It doesn't know what hello world is supposed to be. Now, you know, because you're the software developer, and you understood what you're trying to say, but it got confused by this, and then it sees another set of open and closing, and so it's finding match pairs, but they're not doing what it expected it to do. And so this is another semi-common mistake that a lot of new people will make, is they either only have one quotation mark or maybe they have additional sets trying to embed it. And I'm going to show you a way to fix that later on today, but for right now, let's look at the easy way to fix it. And that is, I can use either double quotes like I did here, or I can actually use single quotes to enclose my string. So if I'm using, if I'm going to print out a string that has an apostrophe in it, maybe I'm using concatenation, so I'm using the word can't instead of cannot, or I'm using your, like you are. Well, then I want to put it in double quotes. But if I'm trying to include double quotes inside my string, I'm going to make my string enclosed within single quotes. And this is a really easy way that Python found to kind of get around that issue. Now, like I said, there's another way. I'm going to be showing you that coming up. But for right now, this is the easy way. But what's something we have to look out for? Every string needs to have a pair of quotes, whether they're single or double, to encapsulate the whole thing. All right, so here is a good example of something just to get us started. Down here in my output terminal, I'm going to clean this up by typing in CLS. That's short for clear screen. This way, we're just going to get to start from scratch. So now we know how to put information out to the screen. Let's now look at getting information from the end user that they can type into that console window. So I might ask a question like, what is your name? Well, if I just say print, what is your name, the program's going to end. It's not going to collect that information when someone goes to type it in. So I need to use a different command. And Python gives us an input command. And we can say input. And notice this is very similar to the print command. It's a name, and then we've got parentheses, and inside we're going to put a string. In this case, I'm going to say, what is your name? And so I have what is your name here. Well, I'm going to save this real quick. And now, by the way, if you do not save something, you go try to run it, it's not going to see the change that you made. You always have to save in Visual Studio Code, especially. Most programming environments will make you do this, or it might do it for you automatically. But Visual Studio Code, you always got to save before you run something. So I'm going to run this, and notice it comes up with what is your name. And I'm going to put my name in here. And nothing happened. Well, that's not true. Python printed out my prompt, and it waited until I gave it some response. Now, I could have put in anything. It doesn't know what my name is. Okay? So I can come in here and I can put in a different name. Bob. Okay? Notice it waits until I put something in. When I hit the enter key, it collects that information, and then it ends because we haven't told it to do anything yet. So let's see, how can I collect that information? Well, in order to collect it, I need to do something called use a variable. And a variable is like a little box that we can put things in, and we can store them for later use. Now, if you've ever had a move, maybe you moved to a dorm room, or you've changed houses or apartments, you know about moving boxes. And you got to put a name on a box, and that way you can reference what's inside the box. You know that, hey, if this says kitchen, you're going to expect things that belong in the kitchen, right? It's not going to be bed sheets. It's not going to be, movies. It's going to be something for the kitchen. Okay. And so our variable names are the same type thing. We need to give it a meaningful name that we can reference. So I can say something like name equals input. This is going to take whatever the person types and put it into the variable called name. And variable names inside of Python are very flexible. They can include letters, numbers, and underscores. They can also include upper or lowercase letters, not just any letters, upper or lowercase, and Python is case sensitive. So this can sometimes cause a little bit of confusion. Now, to help this out, most Python developers only use lowercase letters. It just reduces the risk of you typing in one variable name and using a different one later on because you forgot and you capitalized it in one place and not the other. So most people only use lowercase letters. Now, I have name here, but this is really only my first name that I'm really going to be looking for. So how can I do that? I want to type in first name. Well, if I type in first, this starts to kind of run together, and it's a little bit harder to read. So in Python, what we typically do is we put an underscore between each word in our variable name. Because spaces are not allowed inside of a variable name, but the underscore can be used, and it creates a visual space, but it allows it to be connected. This is actually called snake case. And if you think about it, Python is a snake. And so that's a really easy way to remember it. So that's why we use this type of naming format. Now, if I go and I save this and I run it and I put in a person's name again, notice that nothing has really changed. Well, that's not entirely true because now we're putting it inside of a variable. The problem is we're not using that variable, and we want to use that variable. So let's see how we're going to use it real quick. So I have first name equals input, what is your name? And I want to print out this. So I'm going to say print hello, comma, first. And notice as I start to type, Visual Studio Code is going to come up and say, hey, you've got a variable called first underscore name. Is that what you mean? Well, I'm going to hit the tab key and it's going to fill it in for me. This reduces the amount of typing I have to do, which makes me a little bit faster. And 2, And more importantly, I think, is the second thing that this does for me, which is it makes it so I can't misspell it. Simple misspellings are the bane of my existence. And as a software developer, I am forever fat-fingering my commands. But most modern IDEs, that's an integrated development environment, which Visual Studio Code is, allows you to have some sort of IntelliSense or look-ahead typing. And that means that it can start to figure out, what do you mean? And it will type it in for me. So notice I have hello, comma, first name. Now that comma is very important. My print command can actually accept multiple values. A string literal like hello, and then a variable that we just collected from our input. So if I go and I save this real quick and click run, it's going to say, what is your name? Put in Tom, and notice it says, hello, Tom. Pretty cool. It's now taken that information that we used, stored it in a variable, and then we get to use it later on. Now, this program is really simple. It's only 2 lines long, but this program could have been 200 lines long, and we could have still used first name on the last line. As long as our program's running, we have access to that variable. Now, I can incorporate additional things into that print. So I say hello, first name, comma, I'm glad you're using my program. Notice that I have 2 single quote apostrophes inside of that second literal string. So I'm using the double quotes around it. In doing so, type in Jason. It says, hello, Jason. I'm glad you're using my program. Notice no errors, no problems. That's exactly what we're looking for. Okay, so let's kind of clear that out real quick. And I'm going to use the CLS command once again down the terminal window just to clear that up so we can work again and start with a clean slate. Let's look at some other things that we can print. And we've printed just strings so far, whether it be a name that we got from an input or something else. Well, variables can hold more than strings. And there's a couple of major classifications of types of data we can put inside of variables. String is one of the most common types by far. Nothing wrong with that. Very useful in a lot of applications. The second type is going to be numbers. Now, there are some other types, and we'll look at those in future weeks and future lessons. But right now, we want to focus on strings and numbers. And actually, numbers in Python can be subdivided into 2 major types of numbers: integers and floating point numbers. So let's take an example I have here, age. I'm going to say age is 18. Okay, age is now a variable, and it's going to say, hey, equals, and it's going to take whatever's on the right-hand side of the equals and put it into the variable name on the left-hand side, which is 18. 18 in this case is going to be treated as an integer. An integer inside of Python is just like an integer in mathematics. It can be positive, it can be negative, but it cannot contain a decimal point or a fractional amount. Now, there is one limitation to integers that Python has, and all programming languages have this, that you don't find in math. And that is, in mathematics, I can start counting up in positive integers, and I can keep counting to infinity. Likewise, I can count down and count to negative infinity. That is not the case in Python. In Python, as in other programming languages, there is a maximum value that your integer can be. In most cases, it's going to be plus or minus approximately 4 billion. And you might go, 4 billion? That might as well be infinity. Well, it depends upon what you're doing. So maybe yes, maybe no. If you're talking about a person's age, clearly it is not going to be a problem. If you're talking about the number of atoms that you can find in a gallon of water, it's going to be a problem. And that might blow your mind a little bit to think about there's that many atoms inside of a gallon of water, but there is. But we're not going to worry about that. That's not what we're going to focus on. We're going to focus on smaller numbers are more usable, such as this age. So here we've taken an integer value, we've put it inside of a variable, and I can say print you are and specify age. Save this and click the run command. Notice it comes and says you are 18, no problem. Okay, so I can incorporate strings and numbers inside of a single print command. They just have to be separate into different values. And this age as a number works very good. Now, age as a number works very good because I might check for different things, such as, how many years until you can expect to retire, or maybe how many years until you reach 21, or how many years till you reach some other arbitrary number. So using a number in a variable, or just the number in general, is very good if we're going to do something mathematical. Okay, so am I going to add it, subtract it, multiply, divide, those types of things? I want to store it as a number. And notice the key difference here is that I don't have quotes around it. Neither single nor double quotes. And that's how come Python knows to treat it as a number. If I were to put quotes around this, regardless of if it is single or double quotes, notice that the color of 18 changes. It uses one color for strings and a different color for numbers. It's a helpful little tool to let us keep track of things like this. Now, some numbers you actually want to store as a string. And that might be because of their size or maybe because of other factors. For example, phone numbers or a social security number or an employee number. You typically aren't going to do things like add or subtract those types of numbers. No one goes around at a party saying, hey, who's got the biggest phone number? Okay, so some numbers you're going to treat as a string, and that's normal. And we're going to talk about those types of things both later on in this class as well as in other classes. But for right now, we're going to treat numbers as numbers. So that's our first type of number, an integer. Now we have a second type of number. And I'm going to come down, I'm going to leave a little bit of a blank space just to make it easier to see. So I've got in here, I've written temperature equals 98.6. So in this case, I'm using a floating point number. Notice that the number is still the same color as an integer number. Now, we're going to always show floating point numbers as having a decimal place. However, internally, the computer stores it as a fraction. And to be honest, it's actually an approximation in most cases. And we're going to see this more when we start to add and subtract and multiply those types of numbers. And we're going to see some things later on about that. If I want to look at this inside of a print command, I can say print Once again, I hit the tab key to auto-complete it for me. I'm just going to be a little bit faster that way. Save and run again. Notice it says you are 18. The normal body temp is 98.6. Of course, that is Fahrenheit. We cannot specify a unit of measurement in with a number. We're only storing the number. So we need to use some sort of label or some sort of print command in order to properly identify that. Just something to kind of keep in the back of your mind when you're working with this. Now, obviously, if I was saying that the normal body temperature was 98.6 and I was talking about Celsius, that would not be good, at least not for a human. That would cause some real problems. So we always want to be mindful of things like units and make sure we specify that in a print command if we can. All right, so let's move on and see what we can do with this. All right. Clear out my terminal, select everything and delete it, and kind of start from scratch. So Python allows us to do some real basic math built into the language itself. Addition, subtraction, multiplication, division, exponents, and even the modulus operator is all hard-baked into Python and is readily available for us. Now, some more advanced things such as plotting and graphing and things like that, you might need to use an external library like NumPy. And NumPy is a great library for gives us access to a lot of different mathematical functions that we can use. We're not going to focus on that. Let's just focus on the easy math that we can do. So I'm going to take in, for example, today's temp, short for today's temperature. Okay, and I'm going to say input, what is today's temp in Fahrenheit? Okay, so that's going to be pretty simple, and I want to convert that into Celsius. So notice I have temp C, and I'm going to convert today's temp into temp C. Well, there's a simple mathematical formula that we can use. You can look it up on Google or some other search engine if you want, but it's going to be today's temp in F minus 32 times 5 divided by 9. Now, this is a pretty simple thing, and now you'll notice we're incorporating several different mathematical operators inside this one function. We have subtraction, we have multiplication and division. And Python is going to use the same order of operations that you find in algebra. So you're going to do what's inside parentheses first, then exponents, multiplication, division, and then addition and subtraction. So we need to put today's temp minus 32 inside of parentheses, and then times 5 divided by 9. And this will give us the temperature in Celsius. I can then say print, in Celsius it is, and notice I put temp C. Now you might notice that I put the C capital. You might say, well, why did I do that? Well, Celsius is typically capitalized, and so just for that format and that purpose I made it capital C. It doesn't have to be, okay? This was a programmer's choice. You always get to choose your variable names. I always recommend a good and meaningful variable name. Always, always, always. You could name all your variables X, Y, Z, A, B, C, but when you start working on a larger project, it becomes really difficult to kind of figure out what that was, especially if it's something you worked on weeks ago or months ago. And in some cases, you might be asked to revisit an application that you worked on months or even years ago. I know I have professionally. And so I always try and make my variable names very meaningful, even in something short like this. That way I get into good habits so that when I'm writing something bigger and longer, I'm already following those habits. So let's save this real quick. I'm going to run this. Today's temperature is, let's say, 32. What? I got an error? Well, yes, I did. Let's talk about what happened and why we got that error. Well, very simply, anytime you have the input command is going to return a string value. And a string doesn't know how to subtract from a number or vice versa. And so if you notice, we have a type error. Unsupported operand types for the minus sign, string, and int. It doesn't know how to do it. So what we want to do is we want to convert that string that we have as an input into a number. And a very easy way is in front of our input, we're going to say int, put in parentheses, and then have that whole input command. So we're going to take the output of our input command, what's going to be stored, what the user entered, and we're going to convert it into an integer. And then we're going to take that integer and store it inside of today's temp. Save, run. Now I can put in what is today's temp. Well, it's 32 again. And 32 Fahrenheit is 0 degrees Celsius. I can run this again and kind of test it out, a couple of different things. So I'll say it's 80 degrees, and it comes up and says 26.66666666. Goes on for a while, and then it gets an 8. Okay. And so, once again, this is a floating point number it's generating. And it's generating a floating point because it saw 5 divided by 9. And it says, oh, this might give me a floating point number. And so, what's happening is you're seeing those results. Very simple, very straightforward. Let me CLS my terminal. I want to run one more example. Let's say 98.6. And it gave me another error. This error looks very similar, but slightly different. Okay, so it says value error. Instead of type error, it's a value error. Invalid literal for int with base 10. Now, you might be saying, what does that mean? And if you understood a little bit of how the programming language is created, you would better understand it. So let me break this down for you in very simple and understandable terms. What it's saying is, I found a decimal point, but I'm converting to an integer, and integers don't have decimal points. Well, that makes sense, right? So what is it going to do? It throws an error. That's because it doesn't know, should it just cut off the decimal point? Should it round it? Should it try to convert to a floating point number instead? It doesn't know. It doesn't understand. And so it says, I'm going to throw an error and you handle it. You're this programmer. You're the smart person. You figure it out. So this is a runtime error. We saw syntax errors before. These are examples of runtime errors. The simple solution around this is, instead of an int, I'm going to put float. And float is going to convert this into a floating point number. So I'm going to save, run again, 98.6. And it says, hey, in Celsius, it's 37 degrees. So whenever you're testing an application that you've written, you want to test for a couple different things. Is it potentially valid that a person might put in a decimal point? Yes. Then let's use float. Is it legitimate that they would put in a decimal point? No. Then put it as an integer. So you always want to think about that when you're developing programs. You always want to test those things. Now, later on, we'll show you how to test for that and capture those errors to fix them as the program's running. Because you always have a chance of someone mistyping something or fat fingering it. That happens. It's life. I know I do it as both a programmer and a user. I'm sure you've done it before in your life as well. Other people who are using your programs will too. But that's not for a few modules later on. Let's focus on what we're doing here and now. So I'm going to go back in my terminal window and type in CLS to clear it out. If you're on a Mac, FYI, you might have to type clear. It's a different command. If you're on Linux, clear might be the more appropriate command for you. Now, I'm going to just do some math with two numbers. I'm going to say num1, that's going to equal 8. Num2 is going to equal 14. Okay, so I've just got some basic numbers here that I can use. And I'm just going to show you some real simple ways that we can do the math. Okay, so I'm going to print num1 plus num2. If I save this and run it, you're going to notice it prints out the answer 22. And that's inside my print command. I'm using the plus operator. It sees its two numbers. It adds them as numbers. Okay. If I were to come in here, I could also, of course, multiply. To multiply, I'm going to use the star or the asterisk key. Usually we call it a star, which is Shift 8 on your keyboard. If I save it and run it, it gives me 122. And on I can go with these things. Okay, so plus is addition, minus is subtraction, star is to multiply, the /, or sometimes we'll just call it slash, is divide. And notice it gave me a decimal point number, 0.5714, blah, 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 blah. Okay, so it will automatically say, hey, even those are two integers, I'm getting a floating point answer. And so I'm going to give it to you as a floating point. I can also do a modulus operator. Instead of a slash, it's going to be a percent sign. Now, modulus is something we don't normally see. If I run that, you notice it gave me the value of 8. You might say, well, why did it give that value? Well, your modulus operator says, go back to your early days when you first started doing division, and you had a whole number and you had a remainder. Your modulus gets you that remainder. So let's switch this around a little bit real quick. You see num2 divided by num1. If I run this, notice I get 1.75. Well, I might only want the modulus. I only want the remainder. So I can say print num2 modulus num1. I don't care about what the whole number value is. I only care about the remainder. Notice it's now 6. Okay, it's 1 remainder 6. So this is a real simple way that we can go through that process. And if we need to, we can kind of figure out some of those other things to get that whole number. We're not going to worry about that just yet. Now, the last thing that we talked about that we have in order of operations was the exponent. And we said it's actually very high up. What's in parentheses and exponents, just like in algebra, but we haven't seen how do we do exponents. Well, most languages, you find this very similar for addition, subtraction, multiplication, division, even modulus. But most languages take exponents and do them differently. There's no set standard. So let's show you how Python does it. I'm going to do print num1, and I'm going to do the double star. So star 2. This says I'm going to square something, or I'm going to raise it to the exponent or power of 2. And notice that 8 times 8 is 64. 8 squared, or 8 raised to the exponent of 2, that's 64. And if I come over here and say, well, I want to do it 3, so I want to have 8 cubed in this case, or num1 cubed, I run this again, I get 512. That's the correct answer. And I can go on and on and on with this. So I can come up here and say, hey, 5, and get a really big number. I don't have to use a literal value. I can type in num1 raised to num1. And I get a very large number now with this. And so this gives me a really good and simple way to work with my numbers raised into exponents. Python uses the star operator. Like I said, other programming languages you'll see use different things. Sometimes they have a built-in symbol. Sometimes they have a function you call. We're not going to worry about them. We just want to show you how to do it in Python. So in Python, we've seen how to add numbers, subtract numbers, multiply, divide, raise to the exponent, and put in parentheses. And that's going to incorporate, for the normal programmer, 90 to 95% of all the math that you're going to need to learn how to do. You might say, well, that's it? Yeah. You might say, well, why can't I just put that in a calculator? Well, and if you only had 2 numbers like this, yeah, a calculator would be faster. But where computer programs and computers in general get really good is when you're dealing with lots of information. So let's say I had to read in a data source that had thousands of data points that I convert from Fahrenheit to Celsius or vice versa. Or maybe I had to go and modify prices on 10,000 items. I wouldn't want to do that all by a calculator and then put it in. I would want to use a computer program to do it for me. And so doing these things one step at a time, we're learning so that when we get to reading with files, we can then roll them out in larger formats. But we have to understand that the power of the computer is in its ability to handle large amounts of data very, very quickly. We have to tell it everything to do. So we're the smart ones who have to know what to do and how to tell the computer how to do it. The computer is just going to go and do it very, very quickly for us. So we're building up to those steps, and this is the next step that we're on. All right, so let's look at some basic tips that you might find that make working with Python a little bit easier. Now, there's numerous things that we can do. I'm just going to show you some of them. These are just some beginner tips, some things that I've picked up over my years of using programming languages, including Python, that I've found that makes my life a lot easier. First is I want to comment my code. And commenting my code means leaving myself little notes about what my program is doing, why I wrote it this way, how it's working, so that if I come back to it 6 months or 6 years later, I can do it. And this commonly happens as a software developer. You're asked to come in and write a little piece of throwaway code that's only supposed to be used for a week or two, and it winds up being used 6 or 8 years. I had this happen to myself. I was asked to write a little piece of patch code while we're waiting on the developer to write a fix. Well, they had a fix for us in about 2 months. Problem is their fix actually made it worse. And so my little patch that was only supposed to be used for a few weeks got extended to about 6 months. And so the software company that finally did come up with a patch patched it, and the person who was using it liked my little fix better than the patch software. And so it got continued to be used for about 8 years. Remember, this was only supposed to work for about 2 to 6 weeks. It was running for 8 years. Trust me, I went back to this code repeatedly as I asked for new features. And so writing those comments to explain to myself, what was I thinking when I made this decision? Why did I write it like this instead of some other way? Is really, really important. And in Python, a comment is simple. It's the hash symbol. Okay? You might call it the pound symbol, you might call it the hash symbol, but it's shift 3, and anything after that is ignored by Python. Okay? So this is a comment, because it starts with a hash symbol. Notice that that's not valid code. If I save this and run this, it comes, it runs, it does nothing because we have no commands. Because Python ignores it, you don't have to worry about it not being legitimate code. You don't have to put in quotes. You don't have to put in parentheses or a print statement or anything like that. It is ignored. It is there for you as a developer, especially to go back and remind yourself or show other people what it was. As much as I never liked group projects as a student, I know that most of the things that I worked on as a professional programmer was in a group. And so I was responsible for giving them information and they for giving me information. And if they were away, if they moved to a different job, if they were in a meeting or on vacation, I couldn't just go to them and ask them. So we put comments in our code to let us know one another, sharing that information. Okay. The second thing is sometimes we have large amounts of information. So let's say I want to print a big list of information, and I have dog, cat, turtle, fish, bird, and on I go. Okay. As I start to get longer and longer, I might find this hard to read. I could go past the edge of my screen. And so a lot of times I will go and after a comma, I will break and go to a new line. This is perfectly allowable inside of Python. Anytime we have something like a print and we have something separated by commas, there are other commands that also separate things by commas. just FYI, things you'll see in the future, you can put a carriage return or a new line and go to a new line, make it a little bit easier to see. If I save this and run it, notice it runs, it puts all the information on one line, but it's just broken it up so it's a lot easier for me to use. So notice I have a really long line of code here. There's no commas. Well, if I go and I put a carriage return or I hit the enter key, notice it gives me an error about that. Okay? Because it's looking for that comma, it doesn't have one. Okay? I can't do that if it's one big block of text. But you'll also notice that it goes off the edge of the screen. So in Visual Studio Code, I can do Alt-Z and it automatically line wraps for me. So this is still one line of code. It's not broken up, but it's visually line wrapping for me so that I can see it and I can read all my information. Alt-Z does this. I can also go to my view and select word wrap here, and it will automatically wrap it for me. So there are a couple of ways that you can do this. All right, let's go back to our long list of information here. So it's pretty common if I go and I take this and I run this, you're going to see that I have spaces. And every time I have a comma, that's going to separate out my different strings or my strings and variables or whatever they might be. My separator by default is a space. But let's say I want to make it something different. Well, that's really easy. I can do comma, and now I'm going to type in SCP. This is short for separator, equals, and then I can put a value. So one of the things I can do is a \T. You might say, well, what's a \T? Well, it's what's known as an escape character. An escape character lets me type a character that I can't necessarily just type. I can't hit the tab key. I have to use the escape or \T. Now if I save this and run it, you notice that it spreads things out. It's a tab. Now you notice it spread things out, so they're in columns. And a tab is going to be a certain number of columns of characters, and if I had a really long list, I could start to see things line up in order. Of course, I could do a new line character. New line is a \n, and it's going to put it on each individual line. Now, which one do you want to use? Well, that's up to you. Can you combine things? Why, yes, I can. So \n, \t. But notice my first one looks a little funny because it's not. Yeah, probably don't want to do that. But you can. Okay. So let's look at another example real quick. Print house. And I'm going to do Control-C and Control-V. If I don't have anything selected, Visual Studio Code, when I do Control-C, does the whole line. And so I just changed that to house and car. If I run this, you're going to notice that every time I hit print, or I type in print, when I get to the end, it puts me on a new line. And this is its default operation. And it may be what you want, but there may be times that you don't want that. So let's say I want house and car to be on the same line. I could go comma, end. Okay, so what's going to happen at the end? Well, by default, new line, that \n, but I could do space. Or I could do ... Okay, we have flexibility. It's a string. Anything that we put in there, we will work with. So now notice I have house ... car. Okay, so a lot of flexibility with how I use those sep and end options inside my print command. Also notice, however, that it is only for that one command. So I put in end ... I see house ... car, but notice it doesn't say car ... Okay, so we have to keep that in mind. When I change the separator or I change the end character, it's for that one print command, not for all of them. Okay, very important to remember. So let's just quickly talk about some of those other escape characters. I mentioned two, \T for tab. And if I write a comment, I might do something like this and say, hey, \T, that equals tab. And I mentioned \N, that's the new line, which is a carriage return line feed. And it figures out, depending upon what operating system you use, does it just use carriage return? Does it just use line feed, or does it use carriage return and line feed? Different operating systems handle it differently. Okay, you don't really need to know the history behind that. You just need to know that I go to a new line and my cursor is back at the beginning of that line. Okay. Some other ones that you might see is 2 slashes. Well, that's a \. Okay, so if my \/ is used as my escape character, how do I show the escape character? \/. I can do a \/ single quote, and also, of course, a \/ double quote. So if I'm in a string and I'm encapsulated within double quotes or single quotes, and I have to incorporate that character, I can just do a \/ I escape it, and it gets used properly. So I told you there was another way of handling it. I can use the escape operators. These 5 are by far the most common ones that you're going to use. So those are the ones we're going to look at. The ones you're going to use most often is your new line and your tab. Those are your 2 most common ones. The others are just as needed. Those 5 will handle almost everything that you need to do. All right, so let's look at one more final thing, and that is with our print statements. So I'm going to clear my screen on my terminal, clear out my comments, just so we start with a blank empty screen. And I'm going to say print 8 by 13. If I save and run that, notice I get a 0.61538846 blah 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 blah. That's a nasty looking number. Okay? It's a nasty looking number. So what can I do instead? Well, what I want to do is I want to use a format command. So I'm going to say format 8/13. Now if I just say format, it's not going to do anything. I have to tell it how do I want to format. And so I say format 8/13, then comma, then I might do something like .2f. So show me a floating point number, but with 2 decimal places. So now instead of 6.153 blah blah blah, I get 0.62. Notice it automatically rounds it for me and makes it look nice and easy and good. If I want more spaces, I can say 5, or I can say 0, and notice it rounds it up to a whole number. Okay, I don't have to specify a floating point number. I could specify E for scientific notation, and you can see that there. So there's a lot of things I can do with that number format that I can use. Now, where we're going to see this is if we start doing a lot of work with floating point numbers and more precise things. Now, there is one more little thing I do want to show you real quick in regards to what we've talked about. And we're going to use several things that we've used together to kind of see how that's going to work. And that is, let's say I want to have a constant value that's going to be used inside of a mathematical formula. So we see this all the time. We have a constant that's used maybe in a chemistry value, maybe it's in a geometry formula. And let's take that as an example. Let's take pi. Now, pi is not built into Python. We have to define it. Now, you can find it in some external libraries and stuff, but for our case, we're going to define it in this case. Now, we can't type the pi character, so we're going to type in pi. But as a constant, something that's not going to change, what I'm going to do is I'm going to type this in all caps. This is letting me and other developers know that, hey, when I see this, it should be used as a constant value. Don't change it. So I have here 3.141592. Now, the reason we have to do this way is because Python does not allow us to have a constant value. Now, other languages like C++, Java, and many, many more allow us to define a constant value, but Python doesn't. So this little hack is a way that we as developers have come up with to let one another know what's going on. I'm going to have in here radius. So you're going to specify radius, float, and then inside that I'm going to have an input command. Notice I did a float instead of an int because I don't know if I'm going to get an integer value or a floating point number. I could get 5 or I could get 5.01. Okay, so float is going to protect me. Now I have area equals, and I'm going to store the value of area into my radius. Now, from geometry, I know that the area of a circle is pi r squared. So I'm going to say pi times my radius. I don't have r, I have radius. And just FYI, that's a common mistake that a lot of programmers use. They go, oh, I used a good variable name. And they look at a formula and they go, oh, and they write that formula and they go, oh, something didn't match up. So we always want to make sure those things match up. I need to square it, so remember that's going to be star star. That lets me raise it to an exponent, and 2. Okay? And then I can print the area of the circle is area. I can run this 5.0125 and it gives me a value. Of course, I can take this area and I can format it. Format area .2f. So now if I run this and I type in once again 5.0125, it gives me a nicer looking number. So I'm incorporating several different things. I'm incorporating creating my own variables, using input statements and converting it into numbers. I'm doing some basic math and using those existing variables. I'm using print commands and using the format command to format a number inside that print command. These are all basic things that we've talked about today. And this is really what programming is about. It's about no one of those things is really complicated. What we do is we take little pieces that are simple and start combining them in different ways. And with that, we can make a complicated program. We want to be careful of what we name things so that they're easy to use. We want to make sure we don't have any syntax errors, and we reduce the chance of having a runtime error. Those are two biggest types of errors that we're going to run into, and the only basic types you're going to run into in your beginning programming career. So the syntax errors are easy to find because Visual Studio Code is going to point those out for your Visual Studio if that's what you're using. Runtime errors you don't know unless you test, and so you always want to test. You want to test on a variety of different types of data, not just what you're normally expecting. Test for floating point numbers if that's a potential legitimate value. Test for positive numbers and negative numbers. Test for if you have a string, something that's really long or something that's really short. And so when we start testing, we're going to find these errors and we're going to be able to fix them. Finally, leave comments when you can. Even for something as simple, you might want to leave comments. You might think about it. Where would I put them? How can I make this easier to use later on? When you do that, those are the first steps in learning how to program. Now, in future classes, we're going to look at how do we make decisions so we can change what direction our program is going, how we can do things repetitively, and how we can open files and do other things. So each week and through each module, we'll be building on these complexities, getting more and more complicated until we get to interesting and complicated programs that are useful that we could actually use in a real-life environment. Until then, keep practicing, and I'll see you next class.